Course 1, Lesson 82. Let's start with a quick review. What's a unit of length that we can measure in? How about centimeters? We could say something is 10 centimeters long, right? With a ruler, maybe. What's a unit of area that we talked about last time? Area would be maybe length times width. Maybe this is also 10 centimeters. So length times width, 10 centimeters times area measure could be centimeters squared. Length could just be centimeters, right? How about volume? Have you heard of volume before? We're doing it today. Volume means now we're not just 2 or 1 dimension, we're actually in 3 dimensions. So we use a little 3. What do you think we call that if this was squared? The little 3 is cubed, cubic centimeters. And it means we're going not just length, not just width, but we're now adding height up, like that. Whoa, 3rd dimension. So now we not only want to know the length and the width, but we want to go up and say how many of those bottom levels do we have. You can think of area as the first floor. All the space that the first floor takes up in a skyscraper. Volume tells me put all the floors together. Volume tells me how much space is contained in a 3-dimensional figure, like a cube, like a sphere, like a cone, like a pyramid. So instead of just this or just this, now we're going out into another dimension. That's a pyramid that's sticking out in a weird direction. Okay, that's the basics. Let's see how they describe this. Lesson 82, volume of just a rectangular prism. Just the cube is what a rectangular prism is. You don't have to do cones or spheres or nothing like that. Just the most basic 3D figure, 3-dimensional figure is the prism, the cubic prism, the rectangular prism. Volume is the amount of space a shape occupies. We measure volume by using units that take up space called cubic units. The number of cubic units of space that the shape occupies is the volume measurement of that shape. We select units of appropriate size to describe a volume. For small volumes, we can use cubic centimeters or cubic inches. If it's a larger volume, it might be cubic feet or cubic meters. Makes sense. Pictures representing what a cubic centimeter is or a cubic inch. It's a little block that could make up a larger figure. The base of a rectangular prism is one of 2 parallel and congruent rectangular faces. If that makes sense. I just read that from the math language. To calculate this, we can find by finding the area, length times width, of the base, the bottom floor, and then we imagine building the floors up and multiply that by a height. So basically, volume is going to be 3 amounts multiplied instead of just the 2 like an area. So if this is a cube that's 5 by 3 by 4, to find the volume, you do 5 times 3 times 4, and the answer is in cubic units. So we find area of the rectangle here. Maybe you're imagining it looks like this. Area of the rectangle is 15. Then multiply it by the height. Go up. And that actually tells you how much air is inside, or maybe I was going to say soup in the box, but that doesn't make much sense. Soup's usually in a can, and we're not ready to do volume of those yet. Maybe packing peanuts inside. Amount of whatever's inside this 3D figure. 3D. Okay. Let's practice this a little bit. Formula is V is length times width times height. Why don't you write this into some math notes quick. Lesson, what is it, 81? Volume. Volume is length times width times height. Notice when you're multiplying in a formula, you don't have to write the timesing. You can just write them as 3 letters next to each other. That means multiply. Length times width times height. Not add, multiply when you just put the letters that stand for measures next to each other. Whoops. Give me a sec. So they do it with the one we were looking at earlier. You can do it with just words without a picture. It just says the volume of a rectangular prism, 4 feet long, 3 feet wide, 2 feet high. Those are the 3 measures we need. So 4 feet times 3 feet times 2 feet is 24 cubic feet. You didn't even need a picture that time. Allison put small cubes together to build larger cubes. She made a table to record the number of cubes she used. Cubes along the edge, 2. Volume, number of cubes is 8. 3, 27. 64 is the volume when the length of an edge is 4. Given the pattern, describe a rule that can be used to find the volume of a cube. We can use a pattern to help us find a rule for determining the volume. In earlier examples, we multiplied length, width times height. For a cube, these 3 measures are equal. Okay, notice she said we're using a cube, right? And cubes mean like in a square, length and width are the same. Well, a cube, the height is also the same. However you want to draw this. Okay, so if the volume is 8 and the length of an edge is 2, makes sense because 2 times 2 times 2 would be volume. So with a cube, all 3 measure the same. So 3 times 3 times 3 is 27. So we've found that volume of a cube really is just an edge cubed. Cubed means times itself 3 times. So in a cube, it's real easy. Basically, the 3 measures you multiply are all going to be the same, which means you're cubing it. Times itself 3 times. Clear as mud, right? Okay. Why don't you pick 3 from the examples? Pick 3. Thank you.